We can measure physical properties like distance, speed, and volume in standardized units, but subjective emotional feeling resists direct quantification. There is no physical unit of measurement for fear or love. In 1974, psychologists designed an experiment to test how accurately we actually perceive our own feelings. They stationed an attractive female researcher on two different bridges to interview men crossing them. One was a wide, low, and sturdy bridge. The other was the Capilano Suspension Bridge, which was narrow, wobbly, and suspended hundreds of feet above a canyon. Men crossing the suspension bridge experienced automatic physiological responses, accelerated heart rates, and breathing. The behavioral results: 9% of men on the low bridge called the researcher, versus 39% from the terrifying suspension bridge. They were 4 times more likely to call. The men on the suspension bridge experienced the intense physical arousal of fear, but their brains misattributed that exact same physical arousal as romantic attraction to the researcher. Emotion is not a hardwired reflex reaction. It is a highly complex and easily confused composite of physical body states and mental context. A common assumption in popular culture is the idea that supreme intelligence and rational decision-making require the total suppression of emotion. But emotion is not a glitch in human software. It is a critical, integrated data stream required for executive function. To see why logic requires emotion, we have to reverse engineer the mechanical architecture of how the brain actually constructs a feeling. The biological bedrock of all emotion is the autonomic nervous system, which regulates our organs independent of conscious thought. The sympathetic nervous system alters your heart rate for vigorous action. This visualization shows a biological limitation. Sympathetic arousal is completely nonspecific. These 3 identical heart rate spikes correlate to fear, anger, and joy. The raw physical response provides no distinction. In 1884, psychologist William James proposed a counterintuitive model for how the brain processes this arousal. The resulting James-Lange hypothesis states that you do not run because you are afraid. You feel afraid because your brain perceives your body running. The physical action precedes the emotional perception. We can test this sequential logic using clinical data from patients suffering from pure autonomic failure, a condition where the nervous system stops regulating the organs entirely. These patients still correctly identify situations that call for fear or anger, but they report that the actual feeling of the emotion is severely weakened. Bodily feedback is essential for feeling an emotion's intensity, but it fails to explain how we categorize which emotion we are experiencing. In 1962, Stanley Schachter and Jerome Singer proposed a solution to this categorization problem. Their 2-factor theory established a clear formula. Autonomic arousal determines the volume, but a cognitive appraisal of the situation determines the label. They tested this by injecting college students with synthetic adrenaline. This forced the subjects into an identical, baseline state of physical arousal. The researchers then placed the subjects into rooms engineered with specific environmental variables. One room was designed for euphoria, featuring a playful partner. The other was designed for anger, featuring a highly insulting questionnaire. For subjects who were not informed about the injection's effects, their resulting emotional state perfectly mirrored the room they were placed in. Their brains evaluated the context to explain their racing hearts. But subjects who were warned in advance that the injection would cause a pounding heart experienced almost no emotional shift. They attributed their physical state to the drug, rendering the environment irrelevant. Raw physical arousal is neutral, meaningless data, until the higher-level brain analyzes the surrounding environment to give that arousal a purpose. This 2-factor framework challenges the classical assumption that humanity possesses a strict taxonomy of basic emotions, each with a fixed, biologically hardwired facial expression. Evaluating isolated facial expressions in a laboratory setting is highly unreliable because it strips away the cognitive appraisal of context. A face that registers universally as sadness is instantly recategorized as fear simply by altering the posture of the body attached to it. Rather than treating emotions as rigid biological categories, psychologists use the circumplex model to map human affect. This graph visualizes emotion along 2 continuous axes: pleasure to misery and arousal to sleepiness. States map onto this grid as intersecting data points. High arousal and misery intersect to form distress, while low arousal and misery form depression. An emotion is a highly fluid, multidimensional construct engineered from real-time environmental data. If emotion requires such a massive synthesis of body and mind, what is its computational purpose? Consider the trolley dilemma. A train is coasting toward 5 people. You can throw a switch to divert it, killing one instead. In the footbridge dilemma variation, you must physically push a heavy individual off a bridge to block the tracks and save them. Strictly speaking, the mathematical outcome of both scenarios is identical. One life is sacrificed to save 5. Yet human behavioral response is vastly different. Most people readily agree to flip the switch, while almost everyone finds pushing a person entirely repulsive. This hesitation is an evolved emotional heuristic. The brain uses anticipated guilt to rapidly calculate a moral boundary, executing a complex decision without needing to consciously process the math. We can observe exactly what happens when this emotional heuristic is physically severed from the brain's logic centers. In 1848, an iron bar shot through the skull of Phineas Gage, causing traumatic destruction to his frontal lobe. Modern clinical patients with similar damage reveal a precise neurological mechanism. The ventromedial prefrontal cortex relies on a direct pathway from the amygdala to feed it emotional data. The cortex uses this data, like the anticipation of feeling bad or guilty, to weigh the viability of potential decisions. When this connection is damaged, patients experience a near-total loss of emotional affect, describing their lives with calm detachment. Freed from all emotional bias, these patients do not become hyper-rational. They become entirely incapable of making basic life choices or adhering to social rules. They can rationally discuss the probable outcome of every possible choice, but they cannot decide. Emotion and logic are inseparable. Without the physical arousal and cognitive appraisal that build an emotion, the entire architecture of human rationality collapses.